Are days really getting shorter? On June 29, 2022, the Earth set the record for the shortest day in the last few hundred years, a day shorter than the average day by 1.59 milliseconds. This resulted from the Earth rotating faster around its axis for a few decades. It appears that we would start experiencing shorter days, and the effects of this on our technologies, timekeeping, and public lives could be disruptive, to say the least. But just how bad can a decrease in the length of the day be for life on Earth? What is happening to the planet, and why do we have shorter days? A day as we know it is 24 hours, or 86,400 seconds. This is the time we believe it takes the Earth to complete a single rotation, but it is rarely ever that accurate. The reality is that there are usually some really tiny differences in the Earth's rotation time. Sometimes, it takes millions of years for these changes to actually reflect on our perception of time, and other times, the change happens instantly. In fact, research shows that a day on Earth was about 19 hours 1.4 billion years ago. Several factors can be responsible for the Earth spinning faster, like earthquakes, storms, and climate change. In the past 20,000 years, some of these factors have directly impacted the Earth's rotation. At the end of the last ice age, the melting polar ice sheets reduced the pressure on the Earth's mantle and made it start moving steadily towards the North and South poles. Now, the Earth typically moves faster when the mantle moves closer to the Earth's axis. It is similar to how a ballet dancer spins faster as they bring their hands towards their body, which, in this case, is the axis around which they are spinning. The effect of this is that each century, the days get shortened by around 0.6 milliseconds. In addition, the connection between the Earth's interior and surface play a huge role. Major earthquakes sometimes alter the length of a day. For example, researchers believe the Great Tohoku earthquake of 2011 in Japan, which had a magnitude of 8.9, caused the Earth's rotation to speed up by 1.8 microseconds. The changes caused by earthquakes or similar events like strong winds, volcanic eruptions, and so on are usually very minute, but they are there nonetheless. Small-scale changes in weather and climate also affect the Earth's rotation. They can increase or decrease the speed of the planet, depending on the type of change in question. Changes caused by a spike in temperature are likely to cause the Earth to spin faster, while changes caused by a drop in temperature are likely to slow down the rotation. A good illustration of this is how the fortnightly and monthly tidal cycles move mass around the planet and cause the Earth's rotation to either slow down or speed up by a millisecond. Over the last 18.6 years, tidal variations have occurred in length of day records. The atmospheric movement this causes, along with ocean currents, strongly affect the Earth. Similarly, things like snow cover, rainfall, and groundwater extraction could also come into play. Leonid Zotov, a scientist at the Lomonosov Moscow State University, recently published a study on the Earth's rotation titled Admittance of the Earth Rotational Response to Zonal Tide Potential. In the study, Zotov speculates that the Earth's tides could be the reason behind its rotation fluctuation. Interestingly, after the June 2022 Earth's shortest day, the Earth has switched to a slow rotation again. This slower rotation that has been going on for a few million years can be associated with the effect of friction caused by tides driven by the moon. The 1960s brought a wave of inventions that allowed radio telescope operators around the planet to observe cosmic objects like quasars simultaneously. A quasar is a highly luminous object found in the centers of some galaxies. It is powered by gas spiraling at a high velocity into an extremely large black hole. These observations have led to more precise estimates of the Earth's rotation rate. When these measurements are compared with an atomic clock, they reveal what appears to be a continuous shortening of the length of day over the past few years. But once the effects of tides and seasonal changes are removed from the Earth's rotation speed, what we have left is quite surprising. We see that despite the planet reaching its shortest day on June 29, 2022, the long-term trajectory of the Earth's rotation appears to have shifted from shortening to lengthening since 2020. This is the first time a contradictory change has happened in the past 50 years. The question then becomes, why is this happening now? There is no direct answer to that question. On one hand, we have changes in the weather systems caused by back-to-back La Niña events. La Niña is a weather condition that involves the large-scale cooling of the ocean's surface temperatures in the central and eastern equatorial Pacific Ocean. It causes trade winds that are stronger than usual, pushing more water towards Asia. But they are not a new occurrence. On the other hand, we have the increased melting of ice sheets, though there have not been any significant changes in the melting rate in recent years. The huge volcanic eruption that happened in Hunga Tonga Hunga Ha'apai, a submarine volcano in the Tongan archipelago in the southern Pacific Ocean, is another factor. The eruption reached a climax nearly 4 weeks later, on the 15th of January 2022. Could the fact that the eruption injected large amounts of water into the atmosphere be the reason why the Earth's rotation got slower and started producing longer days? The eruption occurred on the 20th of December 2021, so that is likely not the cause. Another possibility is something called the Chandler wobble, which is a slight deviation in the Earth's rotational axis that happens roughly every 14 months when tides change or winds cause water to shift, or earthquakes cause blips. Observations from radio telescopes reveal that the wobble has reduced in recent years, but scientists have speculated that this strange change in the Earth's rotational speed is related to it, so it could be both phenomena are linked. It is also essential to take into consideration the fact that there have not been any significant changes in or around the Earth in recent times. The change in rotational speed could be temporary changes caused by long-term tidal effects working alongside other periodic processes. Why is it so important for us to have a precise understanding of the Earth's rotation? The answer is simple. Navigation systems like the GPS would not function well without it. So many devices we depend on need navigation: ships, aircraft, cars, mobile phones, wristwatches, and so on. Once in a couple of years, timekeepers insert leap seconds into the world's official timescales to prevent them from drifting out of sync with the planet. This concept was first introduced in 1972 by the International Earth Rotation and Reference Systems Service. The International Earth Rotation and Reference Systems Service developed the leap second to periodically update the Coordinated Universal Time due to inconsistencies between the observed solar time and the long-term slowdown in the Earth's rotation. Today, the UTC has been updated 27 times, the last being in 2016. But there have been suggestions that this alteration can be harmful to the digital industry. Olga Oblyakov and Ahmad Biagoi, engineers at Meta, formerly known as Facebook, published an article expressing why they believe leap seconds are detrimental to the digital sector. According to them, positive leap seconds have caused strange timestamps in data storage that led to the crashed programs or corrupted data. If this trend of lengthened days should continue, the International Earth Rotation and Reference Systems Service may have to incorporate a negative leap second to ensure that we stay in sync with the planet. It would be unprecedented and monumental, and potentially disastrous for the software relying on timers and schedules. Some engineers incorporate the leap second into their systems through a process called smearing. To smear a leap second, they simply slow down or speed up the clocks over a specific time frame. At Meta, they smear leap seconds over a 17-hour time frame because several other servers perform smearing around that time. The smearing process is often very delicate, and so many things can go wrong and lead to an outage on the servers. An example is the 2012 outage that Reddit, a social media platform for discussion and news sharing, experienced, which caused the site to be inaccessible for about 40 minutes. During smearing, the time change confused the high-resolution timer, which sparked hyperactivity on the servers, locking up the machine's CPUs. The network company Cloudflare also experienced a similar outage in 2017. Every time a leap second is introduced, the digital industry runs into problems like the one Reddit experienced. Because the leap seconds are introduced very rarely, it often devastates the community when it happens. Oblyakov and Biagui believe that leap seconds do more harm than good, resulting in disturbances and outages. They are clamoring to stop the future introduction of leap seconds because they believe the current level of 27 leap seconds is enough for the next millennium. But for now, it is unlikely that we may have to rely on negative leap seconds. The only likely development is that once in a while, we may have a few extra milliseconds each day.